Hello Biology. The purpose of this video is to give students who missed any of the 15-1 class notes an opportunity to get them finished up, or possibly I was going too fast, either in class for cohorts A and B or during the Zoom for cohorts A and B and C, but also to give those students that are caught up 1 through 7 an opportunity to finish up the rest. These notes actually do end at number 12. And please remember, these notes are due 9 p.m. on Wednesday, April 7th. Remember, you don't have to listen to me. If you want to mute me and just see me do this, that's totally fine. But you will know that I'm getting ready to advance to the next slide by pointing at the camera, as always. And I will not be spending a whole lot of time on each slide because you can always pause the video and then finish up your typing or your writing. Yeah, so here we go. Let's talk about Chuck and his grand idea. Charles Darwin and his grand, I can call him Chuck because, I mean, we go way back. I've never met him, but I feel like I know him because I know a lot about his work. And anyway, moving on. Here we go. Theory of evolution. All right. So evolution is basically change over time are the 3 words that you need to remember for evolution. But the idea is that modern organisms have descended from or come from ancient organisms, that we have changed throughout time. And now we are different than we were then. By the way, I might have to leave the room. I've got a teenager next door who has been told twice now to be quiet while I'm making a video. And if he continues to scream and yell because he's gaming with his buddies, I'm going to have to go yell at him. Okay, so if I have to leave, I apologize. I'll be right back. Okay, remember, a theory is just one step above a hypothesis, okay? So it's got to be well-supported and testable. And well-supported is important because the way that you become a theory from a hypothesis is you have to have evidence, okay? Now, not so much evidence that you can actually become a principle, okay, which is the next step up, or a natural law, which is the last step, but enough evidence to separate it from a hypothesis. Remember, a hypothesis is just simply a statement about an observation. It doesn't have any data, any evidence, anything. A theory does have evidence. And remember, for those of you that don't believe in evolution, that's totally fine. There are a variety of reasons why you might not. I teach it as fact, but I don't mean to offend. One of the great things, one of the many great things about living in this country is you can believe what you want to believe and you're free to believe what you want to believe. I will teach it as fact, but I don't mean to offend. Please, apologizing in advance if you feel strongly that evolution isn't how it works. I apologize if I upset you or cause any ill will towards you. Okay? All right. How did he get an opportunity to see the world? In 1831, he was the naturalist on a ship called the HMS Beagle. He was a Brit. He was an Englishman. He was not the first choice to fill this job. He also, prior to this, was interested in theology. Theology is the study of religion. He was studying to be a priest. He always had a love of the outdoors, and he had a very keen mind in terms of observation and kind of thinking outside the box. And his father was completely against him going on this voyage. They had a very, very reputable family. The Darwin family name was very important in society at that time, and his father thought it was a complete and utter waste of time for him to go on this voyage. And of course, he saw things on this voyage that led him to his extraordinary ideas about evolution through natural selection. Moving ahead. What did he do on the voyage? He got seasick. He had a very weak, queasy stomach. So and this trip must have been miserable for him. Every opportunity he had to get off that ship and go to the land, he did. He collected, he sketched, he took copious amounts of notes. He was very, very observant. And that detail and not ignoring anything is part of the reason why he was able to figure it all out. All right, so how did he start to develop his hypothesis? Remember, originally it was a hypothesis. It didn't become a theory until more and more and more and more evidence was collected to support the hypothesis, and then it was promoted to a theory. So he studied specimens, drew them, collected them. Bullet number 2 is huge. His understanding of geology, and I myself have a huge love for geology, which is the study of the earth. Matter of fact, I got a conservation biology degree, so I got my biology degree at Sac State, and then I took like an extra year of upper division lab courses to get a conservation concentration in biology. But I also got a geology minor because I really dug some of the classes I took in college. Geology is a study of the earth, and one of the things that Darwin knew, and we'll talk about this in the 15.2 notes, is he read the works. He read a lot of different scientists' works, but particular Lyell and Hutton were two geologists, and their work suggested that the Earth was extremely old. And remember, at the time, in the mid to early 30s, the church ruled, okay? And, according to the church, the Earth was only 1,831 years old because God created everything. Poof, okay? So knowing what other scientists were saying and studying gave him a real advantage in terms of being able to piece all of this information together and to come up with a grand idea. And like I said before, he made lots of observations. He collected evidence. A big thing about his success is he didn't ignore anything. You and I walking, down a path, next to the American River, it's like, oh, that's interesting. And then it's gone. 10 minutes later, it's completely out of our heads. He paid attention to everything. Everything that was interesting to him, he chose not to ignore it. Differences in what he expected, differences in nature that to your average person might be unimportant. He considered all of that important, and he paid attention to everything. And that characteristic, almost alone unto itself, is what got him to the next level, which enabled him to take all of this information and to paint a picture of what it really looks like. And more importantly, to be able to explain it to an average person on the street. Where is it? There it is. Yeah. I've tried to read this book, The Origin of Species, probably 10 or 15 times now. I made it to about halfway through. I'm just not a reader. But he was able to, he's a really good writer. And trust me, you can make a scientific book boring. There are lots of ways to make scientific books boring. He actually was a pretty good writer and could really describe things that even people who had no understanding of science could understand. And this got him a lot of favor from the public after he went public with it, because a lot of people read it and could understand it. And that's one of the reasons why I like teaching evolution is it's easy to understand how organisms that have an advantage in their environment can be more successful. Look at you guys. You're competing with each other for the grades. You're competing with each other for, to get into college. If you're choosing to go to college, you're competing with one another to get the good jobs. And trust me, when we, get to 9, 10, 11 billion people on this planet, that's a lot of competition for living space, for food, for careers, the ability to have the type of family you want to have. It's easy to explain how certain characteristics give organisms an advantage. Okay, moving ahead. All right, process where modern organisms have descended from ancient ones. What do we call that? Take a look back at number 1. Please use this as an opportunity to practice with your notes. Yeah, that's evolution. Good. The idea of evolution, is that a hypothesis or a theory? Take a look at number 2 if you can't remember. You should, because we talked about it a lot. It's a theory. It's the next step up from the basic idea of a hypothesis because it is well supported. It's got evidence. All right, let's move on. He observed that lots of plants and animals were well suited. Better word there would be adapted to their environments. He also paid attention to the ways in which organisms survived, like what characteristics gave them an advantage in their environment, and also recognized that those organisms that are successful in their environment produce more offspring. And of course, characteristics are transferred from parents to offspring. I love teaching evolution right after genetics. Remember, characteristics in the parents end up in the offspring. Now, granted, if we're talking dominance versus recessiveness, that could decrease the chances, but there's always a chance. Okay? So he recognized that these successful organisms could produce more offspring. Okay? Now, this isn't, we haven't hit the home run yet. Okay? God, bless baseball being back. But it's just pieces to the puzzle. All right, speaking of puzzle, how did this puzzle him? How did it confuse him? He was confused by what organisms lived in certain places and certain organisms didn't live in certain places. You could have 2 grasslands that are very, very similar to one another, but completely different organisms living in these environments. And again, somebody who's not all that interested in this or not really observant could walk, and go, that's odd. And then it's out of their head in 10 minutes. He paid attention to this and he came up with ideas about why different organisms were living in similar environments. What about this environment? What about these organisms give them an advantage to living in these environments? Because trust me, you're not living in an environment unless you have what you need characteristics-wise, traits-wise, to live there. You're going to go somewhere else if you can't survive in that environment. Unless we're talking about the mass extinction that's currently happening on this planet. Lots of mass extinctions in the history of this planet. But the rate at which organisms are disappearing from this planet on a daily basis is startling. And the big reason between past mass extinctions and this one is we weren't here during the past ones. We weren't burning fossil fuels. We weren't changing the environment as quickly as we are. Organisms can adapt to an environment if it changes over thousands of years, maybe hundreds of years, but we are changing the planet's climate and environment in under 100 years. Organisms can't adapt that quickly. And if you can't adapt, you die. Moving ahead. All right, so fossils. Some of the fossils he collected resembled organisms that were still alive. He's scratching his head. I've seen organisms similar to this. I wonder if they're related. Just like me.